Good morning, everyone. How you guys doing? Thank you so much for coming. We really appreciate you being here at 8 a.m. this morning. Some of you were even here at 7:30. I wasn't, and I was seriously so close to not making it this morning, but I'm glad I'm here. And let's talk a little bit about connecting and transforming data using Power BI and Excel. I'm Miguel. I work on the Gateways and Connectors team, part of the BAPI organization, part of James' team. We actually work on connectivity across all of our products and services, including things like Power BI, analysis services, Power Apps, Flow, Logic Apps. So all of the data connectivity layer our team manages, including gateways as well. And I have a pleasure to have with me today Guy Hankin. He's from the Excel team, where we also provide connectivity features.
Hi, my name is Guy. I'm a senior program manager in the Excel team in Israel, sunny Israel. And I work on the get data experiences in Excel.
Okay, so let's get started. Before going into the agenda, actually, I wanted to ask, how many of you are already using either Power BI Desktop or Excel to create reports and analyze data? Okay, so this will probably be, well, actually, this is one of the widest rooms that I've been presenting on, and flattest. So, like, when I ask something, it feels like watching a tennis match over here. Like, any Nadal fans? Okay, good. Few of you. Good. Okay, so I wanted to ask also, how many of you have actually already been using Power Query in Excel in the past? Okay, few of you. Okay, good. So for some of you, the beginning of the session, the overview is going to be a little bit of a refresher on the basic concepts. And then as we progress, we're going to do a bunch of demos, and we're going to be doing increments in terms of the skill level and the depth of the knowledge that we're going to cover. Just in case you don't know, there is, right after this session, there is a deep dive into the M language that's happening at 9:10 a.m. Upstairs. So I recommend you guys to go there because it's a perfect continuation to this session where it's going to be more UI focused. So we actually set it up that way on the tracks, so that you get the increments, first UI, then M language. So let's talk a little bit about the demos, and then we'll also show you some of the coming soon features, some of the connectors we're working on, and some other exciting stuff. Let's talk a little bit about data acquisition, data connectivity, and data preparation in the data analysis and BI world. So as you all know, finding data is very easy. It's easy to connect to data. It's always available. The experiences for connecting to data are easy. Even when you use different tools, they're also easy to learn, right? And when you connect to data, it's always in the shape you need. Like you want to build a report, you want to do an analysis, there's always that data set that's perfectly shaped for what you need. And if you need to actually do some transformation, some filtering, it's so easy, it's quick, it takes no effort, like a couple minutes, you're done. And of course, if you need to combine data across multiple sources, that's also pretty easy, right? And the data volumes, usually you work with tiny data sets, they're easy to manage, they're all ready for you to consume, and even if data doesn't come from a single data source, when it comes from multiple, actually refreshing data across sources is also very easy. Right? Sure. I think you guys are sleeping, but not that much. So I think you caught that was sarcastic. So in reality, finding and connecting to data is so hard. You don't know where the data is. You need to go ask someone who knows somebody who knows where the data is and that kind of thing, especially on large organizations. When you actually figure out what's the data set you want to connect to, now you need to get credentials. Once you get credentials, you need to figure out where to put them in. You need to figure out which tool you're going to use for that. And lots of considerations go into that. You also then, once you connect to the data, figure out that it's not in the shape you need, so you need to go do lots of operations, either to subset the data to a specific date periods, or maybe you need to normalize data, especially when you're working with data from different sources, like maybe Excel with some database data, or maybe with some web service data, or web-based data. You need to normalize it because sometimes you need to do joins, you need to correlate data, and there's never in the same shape. Like codes are always slightly different, company names, and all that stuff. So there's a lot of custom logic that you need to put into just cleaning up your data so that you can correlate it, so you can bring it together. In many cases, with older technologies or other technologies, it's not straightforward to do these things. You need to learn the query languages for each of the data sources you're connecting to. Like if you're connecting to SQL Server, you need to type some T-SQL in. If you're connecting to something else, you probably need to learn another language. And it's also not easy to join that data together because then you get the problem, okay, where do I actually join it when I'm working with SQL and this other Hadoop source? Like, where do I do it? So you end up doing a lot of manual work, downloading stuff, caching it locally maybe, and then doing that operation there. And the last point here is about the 3 Bs of big data. So usually when people think big data, they think large data volumes, but it's not just the volume, it's also the velocity, the difference on the frequency in which the data sets change. You might be working with a data set where it changes every minute. Another data set might change once a month. So how you actually correlate that and handle that difference in the refresh frequency when you're actually analyzing data across them. And the last point here is the variety, so the wide range of data sources, relational, files, big data sources, websites, and all that large variety of data sources. IoT data, of course, not want to forget about that. So that's the 3 Bs of big data. Now, how does Power Query help? First, talking about variety, it gives you connectivity to a wide range of data sources. We support 75 plus data sources right now. And there's actually way more than that because out of those 75 that you can see called out on the list, there's many data sources that will allow you to connect to third-party data sources through generic interfaces. Things like ODBC, OLEDB, OData, REST APIs, they're all supported. So even if a data source you're trying to connect to doesn't show up on the list as a first-class thing, you might be able to connect through one of these interfaces. And connecting to the session that's coming later, the deep dive into M, we're also going to cover the Custom Connectors SDK, which is something that we just announced a couple of weeks ago. How many of you have heard about the Custom Connectors SDK, the Power Query SDK? It's a developer toolkit that allows you to create custom connectors using M, using the underlying formula language. So for example, if you have a third-party data source that you don't have a first-class connector to in Power Query, in Power BI, or in Excel, you can actually use the Custom Connector SDK to create a connector on top of, let's say, an ODBC driver or a REST API, and then be able to distribute that to your users, to your customers, so they can actually just use it seamlessly plugged into Power BI or into Excel. So more on that on the next session, but just so you know that it is there. The second point here is that we not only give you connectivity to those 75 plus data sources, but we also give you a UI-based experience for connecting, previewing that data, figuring out the data shapes, and then applying operations, applying transformations and filters by example. Every time that you connect to a data source in Power Query, you're going to be working on a preview of a data set, like the top n rows, and you're going to be able to start defining the set of transforms that you're going to apply through the UI. Like, for instance, removing columns, excluding certain rows, doing an unpivot operation, doing joins, doing unions. So this experience is very consistent across all of the data sources that you work with. It's pretty much the same UI. In some cases where we work with a smarter backend, something like SQL Server, for example, we're going to be able to push many of those operations to be executed on the backend. So for instance, if you apply a filter operation in the query editor UI, we're going to generate some M code that does a select rows operation with a certain condition. The M runtime is going to be able to push the execution of that into T-SQL in the underlying SQL Server engine. In other cases where you work, say, against a CSV file or a website where you're scraping some data from HTML tables, there's no backend to push that down, right? So in that case, the M engine will perform the operation locally. It will compensate for the lack of those query execution capabilities in the data source. As we were saying, this experience is consistent across all of these data sources, and we also make it really easy for you to combine data. There's two main ways to combine data using Power Query. One is doing merge operations, which is basically the equivalent to a join operation in database terms or to a lookup operation in Excel classic terms. The other one is unions or append operations, where you basically add rows at the bottom to an existing tables when you have multiple tables with the same set of columns. And the last point here, this Power Query experience, we make it consistent, and it provides connectivity for all of these Microsoft BI solutions, including Excel 2010, 2013, Excel 2016 being inbox, so being in the data tab without any additional add-in installations or anything. Power BI Desktop, if you've used that, the Get Data experience and the Query Editor experience, that's common across Excel, Power BI Desktop, and also in the new version of Analysis Services in SQL Server BNext, the developer tools, which someone would use to create a analysis services data model. It's actually powered by the same Power Query experiences. So let's take a quick look at that. Let's look back at 2013. This is the data tab in Excel. There was a set of connectors there under the Get External Data tab, or the Get External Data group that have been there for some time. It provided connectivity to things like Access, web, text. If you go to the other sources dropdown, there's actually a few more, like SQL Server, analysis services, or data. Who recognizes this second tab here, this second screenshot? Anyone? Yep. The second one is actually Power Pivot. This is the data tab in Power Pivot. So Power Pivot was it's still a great tool for actually doing in-memory BI analytics. It's powered by this really powerful in-memory BI engine called Vertipaq or XVelocity, however you want to call it. Has this awesome language as well for data aggregations and calculations called DAX. It also provided some data connectivity capabilities out of the box that kind of enriched the ones that Excel provided back in the day. But the main focus of Power Pivot is not data acquisition. So when you actually go use the data acquisition in Power Pivot, you realize that you don't have as many data transformations or preview capabilities as you wish you could have, or as something like Power Query could give you. And of course, at this point, we already have 2 data tabs in Excel, and that causes some confusion. So we said, well, we might as well introduce a third data tab to clear the confusion. So that's Power Query, which was available as an add-in, or it's still available as an add-in in Excel 2010 and 2013. And it provides additional connectors, additional data transformations, so it makes even more confusing, right? So we said, OK, we need to fix this. And in order to fix this, we kind of sat together with Power Pivot and Excel teams. This was 4 years ago, I think, 4 or 5 years ago. And decided that Power Query is the way forward in terms of data connectivity and data preparation for Excel. And with that in mind, we embarked together on this great adventure of integrating integrating Power Query into Excel 2016. So if you use Excel 2016, this is a screenshot of the RTM version. You'll see that in the data tab, there is the Power Query capabilities under the Get and Transform group, which you see here, it actually coexists with the Get External Data group that we were talking about earlier. This was a stepping stone, and I'll leave it there. So Guy will cover a little bit more on the future direction for Excel. I'll just leave it there. The second experience we were talking about was the Get Data experiences in Power BI Desktop. So here's the Get Data screen with all of those 75-something connectors. This is the same experience in the SQL Server BNext data tools, as we were saying. So as you see, the same Get Data dialog, a little bit of differences in the number of data sources exposed in one client versus the other. This is just point-in-time things around integration. Eventually, we want to get to where we have the same set of connectors across all. The query editor experience, this is actually common across all 3 with the same set of transformations in all 3 products. And it gives you all of those data prep capabilities that we were talking about and that we're going to demo right soon. So with that, let's go into demos. Enough for slides. I'm going to be doing a bunch of demos using Power BI Desktop, and then Guy is going to do a few demos using Excel as well. But keep in mind that everything you do here transfers to the other tools as well. We're going to go get some data. And we're going to start with something like SQL Server. So we have a bunch of file connectors here, databases, Azure services, a bunch of other online sources. We'll go use databases. We'll go use SQL Server. And I'm going to provide my server name. I'm going to leave the database as optional. So here I could pick between 2 different connectivity modes. This is a feature that's specific to Power BI Desktop that basically allows you to say, for certain data sources, I want to import data, which means I want to extract data from the remote data source, and I want to bring the data down into the local in-memory engine, which is the Vertipaq engine we were talking about, the analysis services engine running behind Power BI Desktop. That would be ETL. That would be the first mode, import. The second mode, direct query, which is what I'm going to use in this demo, is actually going to bypass that extract step, and it's actually going to just create a live or direct connection between the schema defining analysis services with the underlying data source. And as you start creating visualizations in your report layer, or as you start creating measures in your model, we're going to dynamically resolve those, and we're going to reach back to the underlying data source with specific queries that we will run at, say, runtime or even report consumption time to bring the latest results. So for example, as we build something like a measure for total sales, we're going to actually run a sum of the sales column on a given table. We're going to be executing that at runtime. Likewise, if you create a chart that has total sales by categories, we're going to actually send group by operations to the underlying data source for that operation. So let's go with direct query. At this point, I would get asked for credentials for my data source, but because I had already connected from this machine, it's actually going to remember my credentials, so that's why I'm not being prompted. But that's what would have happened there. So now I'm seeing my server, Monteuro F6, with a bunch of databases in there. This is the navigator experience. And here is where you can actually browse all of them and find all of the tables. You find views as well. You can also find functions to execute. So there's a few things here. As I select one of the tables, you see that the right pane actually shows a preview of that table. And you can select multiple as well. So let's say I want to select categories and customers, maybe do order details. And I can also click select related tables, just because I'm kind of lazy today. And that will basically select all of the tables that have an existing relationship in the underlying data source, in this case SQL Server, to the tables that I had already selected. So when I selected those two, it actually brought up another 3. So with that, at this point, I could do a couple of things. I could do load, or I could do edit. If I click load, it's going to go straight and load the definition of the tables. In this case, because I'm using direct query, it's just the definition. It's going to load that definition into analysis services, into the model. And then I'm set. I'm ready to go start creating my visualizations. If I were to click edit at this point, I would go into the query editor. And that's where I could start pre-filtering and transforming the data before it even gets loaded into the data model. In this case, there's no data download in between. But that could actually be very helpful in terms of subsetting the data before you ETL the data locally. In this case, I'm just going to go load, and this is going to create that live connection or direct query connection to the data model. So you see in this mode, we have this message that says direct query enabled. You can actually change that if you click here. If you change your mind, want to go to import, you can do it easily from there. But I'm going to stick to direct query. So let's do a few things. Under order details, we can maybe add something like a new column. So let's say I want to create my total sales, because I don't have total sales. I only have in this data set the unit price and the quantity. So let's go and do that. Now that I have total sales, I can just drag it into the canvas, and I can turn it into a cart visual, and you see that the number came in. It actually was pretty fast, but it actually evaluated in the underlying data source. Now you could do something else like for instance, let's do total sales by product category. So we can grab category name from the second table, and we can turn this into a bar chart, and now grab total sales into the value. So you see that it also resolved pretty fast. But now as I interact with the visuals, it's still pretty fast, but you need to believe me, but it's actually going to the underlying data source. Probably they're simple calculations. So just an example, in this case, we're actually creating a custom measure, and we are relating to another table, categories. That's all happening out of the box. You get the right results there, because we're actually recreating those relationships when you load data. So if you see here, if I go to the relationships view or the diagram view, you see that we loaded relationships across all of those tables. And we did this through the get data experience. When we were selecting those tables, we detected the schema, we detected the relationships in the source, and we just propagated them through. OK, so let's go into the query editor. We can click edit queries and get there. In this case, I'm actually not going to do any transforms, but just to show you, we got one query for each of the tables, and we got a few steps for each. In this case, it's just the source step, and then the navigation to the specific table we picked. So let's go and do something more complex. Let's start a new Power BI desktop window. We're going to go and do something now that will require some data transformations. Here's the scenario. I have a table with movies, with the highest domestic gross movies for this year, 2017, in this website. And I would like to actually build a report on top of this data. So what I want to do is actually scrape the data out of this page and just have a report that works that way. Now I could do it with copy paste and that kind of thing, but it will be a one-off thing. And what I really want is to actually build a report that I can schedule refresh for and have my Power BI dashboard refreshing on top of this, maybe even sending me alerts when a movie goes past a certain total gross. So what we need to do is copy the URL, and we go back to Power BI Desktop. We're going to go get data, and in this case we go to the other sources category and we have web. The web connector allows you to do two main things. One is importing data from a web API, as we discussed before with REST APIs, or you could also scrape data out of HTML tables on an HTML page. Let's go just paste the URL. We're going to do exactly that, scrape data. And now the navigator dialog, which as you see is pretty consistent with the experience we had with the SQL Server connection we established, is going to list all the tables in this website. Table 1 happens to be the one that I want, so it's kind of easy in this page because there's just a couple tables. But if you needed to go and preview the data in context, you could also go to the web preview, turn that on, and then you'd actually see the website just like it looks in the browser. And you'd be able to even select from here table 1 and then go into load or edit. In this case, let's go do an edit operation. We're going to go into the query editor. You see how at this point we've actually already done some data transformations for you. It says change type, but everything looks like text. So we need to actually figure out why that's happening. If we look through the data set, we go all the way to the bottom. You see that there's 3 rows that do not actually belong to the data set. If we go back to the web page and we go to the bottom of the page, you see that the bottom 3 rows here belong to the table in the HTML code, but they're actually not of the same schema as the other rows. So we need to clean that out. Let's go back here. We have a bunch of operations in the ribbon, data transforms. One useful group is removing rows, so you can remove rows from the top, from the bottom. So what we're going to do here is remove the bottom 3 rows. And just with that, the 3 rows are gone. So now we have 100. Oh, this is funny. The 100th movie is called 3 Idiots. I like that. All right, so now that we've cleaned up the last 3 rows, we can just go and remove a few columns as well. So let's say I only want to keep these ones. I'm going to remove other columns. I love remove other columns because it basically says I only care about these 4. Even if there's more columns coming into the original data set next month, next year, I don't care. Don't bring them in. Like, I don't want extra columns that could mess up anything or introduce conflicts in my data set. So that's the main difference with remove columns, where it basically just excludes a few. And then if there's new columns coming in, you'll get them the next time you refresh. So we cleaned up the columns. Now let's go and clean up the column names as well. This would be just movie title. And this one is actually just the total gross. It's not the theaters. So now that we have cleaned that up, we can go and clean up the types as well. We could do this one by one, or I could just go into transform and say detect data types. And that's going to fix up my column types. It's going to turn this into number, this one into currency, without having to go doing it one by one. OK, so fairly easy, right? We brought one table. Now we could load this. We could report on top of this. And this is the top 100 movies. But if you realize, back in the data source, we actually have multiple pages of data, because we have up to 293 movies. So we have 3 pages of data. So our next task is going to be figuring out how to bring those additional pages and make it such in a way that if there were 2 or more pages or 3 or more additional pages next time we refresh, they should also come in. Let's do that in a couple of different steps. The first one, if you look back at the URL that we were using in this website, you notice that there is a get parameter for the number of pages. Page equals 3, page equals 2. So we need to go back and parameterize what we did in our query so that we actually can introduce that dynamic number. We go back to the sources step. We had that static URL with page equals 1. We're going to actually change that. There's 2 modes in the web connector. There's basic and advanced. So if we go into the advanced mode, we're going to be able to split our URL into multiple parts. So I'm going to, for instance, remove that page equals 1 from that part 1, and I'm going to say page equals 1 in that second part. Let's actually say page equals 2. And when we do 2, and I go to the second step, you see that now we're loading movies from 101 to 199. Now we actually want to make that fully dynamic. Instead of hard coding the second parameter, we want to parameterize that, right? So let's go back to the advanced step. And here you have, well, let me show you how to enable that, because you're probably wondering where is that control coming from. You have a parameters option under the View tab. You can always allow this. Or if you don't allow that, you can always go to the Home tab and create a new parameter from the Manage Parameters section here. So let's go back to my View tab and always allow to show the parameter control. So this drives the visibility of this control over here. So I'm going to switch from hard-coded text to actually make this second part a parameter. And I want that parameter to be called page. And I want it to be of type text. And it could have any value. So I could actually subset this to a list of specific values that I could call out here. Or I could make this dependent on another query that returns a list. In this case, I don't have any other list query. So what I'm going to do is just keep this as current value, as any value. And I'll give it a current value of 3. So we're going to load movies starting at 200 now if we go back to our table 1 output. So C201 now. OK, so the next thing, now that we have parameterized that step, is to actually generalize this query with a parameter into a function that could take any input value for that page value. Fairly easy to do this. I just need to right-click here and say Create Function. And once I do that, Power Query is going to analyze your query, and it's going to let you provide a name. And it automatically detects that we're using a parameter called page in that query. So it assumes that the parameter that you want for the function is going to be that one. Just by confirming that, you actually get an extra query. So we actually do some grouping here. We keep a group here with the output. And then we also have the original parameter. And now we have the new getPage function. So now I can invoke this getPage function, maybe with page 1. And I'm going to get the output of that with just another query that returns getPage with page 1. Now what I actually want to do is something different. I would like to create a list of numbers. So let's say something like 1 through 10. And I get 10 different values here for page. So now I'm going to invoke getPage over this table, row by row. And to do that, I can just go to Add Column. And there is this invoke custom function that basically will allow me to pick any user-defined function in the current file, in the current PBIX file. In this case, there's just one, getPage. And I can specify an input value, which could be hard-coded text, or it could be a reference to another column from the current table, which in this case, there's just column 1. And this is actually going to fail, because I need to turn this into text first. Sorry about that. So now if I select getPage with my column 1, that's actually going to give me the output. So as you can see now, there's actually tables for the 3 first rows. So this page 1, page 2, and page 3. For the following indexes, there's actually an error because we couldn't find any page with page equals 4. There's not enough movies this year yet for that. So this is a little trick. You always can put a number there that you know you're never going to hit. And then what you can do when you get these errors back is just use the remove rows with errors transform. So you select get page and do remove errors. And that's going to narrow it down to, in this case, the top 3 rows. But if tomorrow we get a 4th page, that would actually work as well. And now when you expand the nested data, you get the full set with the 283 movies. All right, so that would be for the second demo. We kind of covered importing data from a website, using query parameters, and then using functions, and also a couple of additional transforms. Let's go into another demo, something that's pretty common. You get many different files periodically, the same file every month or every week that has the same schema, and you actually need to bring them all together to actually create a single report. Think something like weekly sales, monthly sales, weekly visits to a website, you know, all that kind of weekly reports with the same type of structure. Let's look at an example. Not yet that one. Let's look at another one first. Let's imagine that I have something like let's say that I have a file like this. It just has monthly sales data for each city and the product category for a given month, 2015-03 in this case. And let's say that I have a folder full of files that have the same structure for each subsequent month. Now let's go and bring that data into Power BI Desktop. We're going to be using the folder connector, which effectively allows you to point to a specific folder and then do operations on top of all the files in that folder at the same time. You can either analyze metadata of the files, or you can actually combine the data on those files and then get that single data output. So we're going to go get data, use the folder connector. We're going to browse for that folder. Work folders is my demo. Data Insights Summit, PQ overview, inputs, monthly sales, tables. So that's the current folder. And now we're going to get a list of all the files in that folder. And at this point, I could do load or edit and report on top of this. But what I really want to do is go edit this data. Now, within the query editor, there's a couple of ways you can combine data. You can actually do combine files from here in the ribbon. Or you could also click into the combine icon that's on the column header of the column that actually holds the binary contents for each of the files. If I do this, we're actually going to analyze the files here, and we detect that they all have the same extension, so you probably want to just do something like importing from an Excel file. And we're going to show you, based on the first file as an example, and I could always change that to a specific file, we're going to show you the tables and the content that we found in that Excel spreadsheet. So in this case, there's a couple of things. There's the table and there's the worksheet. We're going to go use the table. We could also skip files with errors. So in the case where we select table 1, but then five files later we don't find that table 1, there would be an error, right? Table 1 not found. So we could also tell Power Query to skip the files that don't look the same. In this case, we'll just keep them. They're actually all homogeneous, so that will not happen. And once we do that, we're going to go and create a few things. Looks like this. You're looking at the output query. So in this case, it actually gives you the exact shape you want it. This is the union of the data on all files. You don't need to worry about anything else. Now, if you're actually curious about what's going on behind the scenes, you should listen into the next minute, which is we create a folder that has a few intermediate or helper queries. One of them is the function. So we're following actually a very similar concept to what we did in the previous demo, where we internally define a function that has the logic to extract data from a single file. So similar to what we did with that web page, for a single page, we have some logic to exclude rows, to pick a specific table, and then we parameterize the file path. And then we have the list of file paths that come from the folder query that we started with, and we pass that and we invoke that row by row, and then we expand the data. So pretty much what we did in the previous web demo, except that in this case we're doing all of that for you because it's a very common pattern. So the queries that you end up with are the function query that basically is the one that then we end up invoking for each row. There's this transform sample file, which effectively allows you to come back and apply additional transforms if you want. Once you apply a transform here, it will actually get reflected in the function. So they're both linked behind the scenes. So when you make a change here, for example, if I go transform this data into, say, uppercase, this first column with city, and now I go to the output query, we're going to see that the city column has been uppercased. That's because we, based on changes in this transform sample file, we propagate those changes to the function, and then when you select this query, we reevaluate that function and reapply that. There's a couple more queries that hold the parameter for the file that you want to use, the sample file, and then the actual binary for that file. These ones you actually don't need to worry about at all. So with that, it's that easy to actually combine data across all of those files. Let's actually go and do a more complex case. I'm going to start a new Power BI Desktop instance here. Let's look at this other file. So this one file actually has kind of similar data, but is not structured in the same way. So now for the human eye, this is actually pretty easy to understand that we're looking at data for a few years, and we're looking at 3 cities. And we kind of assume that because of this separation and these empty columns here, these 3 columns apply to Seattle, and the next 3 apply to Portland, and then Vancouver, right? We know this, but Power BI or any analytics tool doesn't know this out of the box, so you kind of need to help it understand it. So let's go back to get data, and we're going to do that also using the folder connector, except that in this case we're going to have some extra logic to extract data from that specific file. Let's go point to that folder, work folders, demos, data insights, inputs, monthly sales. Okay, so this is kind of a rinse and repeat from the previous demo. We're going to go edit, and we're going to go combine binaries. Now, in this case, when we do that, we're going to see that the data we find in this file is just a worksheet, and it doesn't look quite right. It looks pretty, unintuitive. So when we do that, we're going to get the output that's combining all of those rows of data from all of these files, and of course, it's going to look like a dog's breakfast. It doesn't really make any sense, So we need to go and clean that up. We can go to the transform query, the one that I told you that you could always come back to and make changes. And here we're going to do a few things. We're going to go do a transformation to transpose, basically turning rows into columns. And now this starts looking better. The first column now we just need to fill down values. So we propagate the city name to the next two product categories. And now we can fix the actual column names. So this would be my category, and this would be total sales. So this actually looks much better. We can also detect data types. And now this is pretty much the shape we want it now for a single file, right? Now we go back to monthly sales. There's this error. We're kind of optimizing here for the case where you don't transform data with custom logic. So we apply a change type step that assumes that you're not going to change your column names when you go modify the sample query. You can always come back and remove that step. And now it actually works. You can actually redetect data types. And now it's exactly the shape you want it. It has the data on those files with those 3 columns, plus an extra column with the actual source file name, the name of the file that it came from. So you can even do other things here, like let's say I want to split this column by the limiter, and I would like to use the period, and I want to do it at the rightmost delimiter. And now you actually end up having a date. So that's pretty awesome, right? You automatically get the date based on the file name that you get dropped in that folder. The key point here is that as you refresh this query next month, or we refresh this query next month, you're actually going to get the additional files that were dropped into that folder using the same logic and the same scheme, and the data is all up to date. All right. So trying to make things easier. This has been a very common request from users to make things easier. We always love things being easier. So could it be even easier if you just told Power Query, OK, this is the output data that I would like to see, rather than telling Power Query, OK, this is the set of transfers that I would like to apply. So let's go and cover that. We actually recently shipped a feature that does exactly that. How many of you have seen the Add Column from Examples feature? OK. So for the rest, I think it's going to be a great experience. Don't close your eyes, because you're going to see some magic. Let's go get some data. In this case, we're also going to use another website. This is a Wikipedia page that has the list of states and territories in the US. You scroll down, there's a table here. And living in the US, I thought it would be good to actually monitor this. You never know what can change these days. So let's go and connect through web. And I'm going to build my own report to see how many states there are in the US and things like that. So in this case, it's pretty much the same experience you saw earlier with the navigator. We get way more tables here, but luckily they actually have good captions. So there's the States of the US of America table here that I'm just going to use. I'll click Edit, and I'm going to go into the query editor again to do some query shaping. Where is my query editor? Oop. Where did it go? OK, here we are. All right, so here's my table. I'm going to do a few things. It's not looking right. I don't know what's going on. Let me do a little trick. OK, this is much better. Delete that. OK, so here's my table. I'm going to go exclude a few columns first, so I'll do remove other columns. Let's go clean up the column names. State, abbreviation, and this is the city's largest. OK, So now let's go and use the by example experience to actually extract some data. If you look at the state column, you see that Massachusetts down here actually has square brackets E. So we need to clean that up. Now, a way to clean that up could have been split column by delimiter, or maybe replace the square brackets E with empty. That wouldn't work because we have other cases with square brackets F and things like that. Those are actually links in Wikipedia. So let's go and do column from examples. And it brings me into this experience. Let's actually minimize this guy for now. It brings me into this experience where I can type into this new column the values that I would like to see as the output. For example, if I go to Massachusetts, to the Massachusetts row, and I type Massachusetts, it's actually automatically going to detect the transform to apply, and it's actually going to give me a hint for what the output values would be in the other columns. If you look here on the command bar, you see that it detected the following transform. Text before delimiter on the state column and the square bracket delimiter, which is exactly what I wanted. So I'm going to go commit that. And boom, I have my new column. Isn't that cool? Let's go do a few more. Let's go and bring an extra column, which I actually forgot. So I'm going to go edit one of my steps here to bring the statehood column as well. And you can always do this, go back on the steps pane and kind of edit in a step that you had already configured. So now that I have my statehood column, let's clean up the name as well. I'm going to go extract data from it. So we could do something like extracting the year when a given state was founded, like 1819 would be year from the statehood column. And you get these suggestions that basically allow you to select from a set of out-of-the-box transforms. So with that, we get the year. We could also do something like getting the month name. So let's do that as well. So this was December. And it detects all of the others. And we could even do things like weekday name. So we can do extract from all columns. And I know this is a Tuesday, but it's also called out here. So it helps me with that. And now I have my weekday name as well. And it's not only about extracting data, you could also combine data together. So let's say I wanted to build a column that creates some legend or something that I want to do, that I want to use in one of my visuals. So I could say something like, let's use Alabama with AL, whose capital is Montgomery, was founded on a Tuesday in December 1819. So if I do that, it's actually going to get it almost right. It missed one thing because it got confused with capital. It thought that we were using capit with the concatenation of the abbreviation column. So in this case, we need to disambiguate. And for that, we need to provide the second example. So if I go to the second value here, you see that for Alaska, it had actually detected who's Capitac, because it's using AK instead of capital. So if I just fix that letter and move away, now it's actually doing what we want. So I can commit that, and it's going to give me that new column with a full value, and it reads exactly as you would expect. Pretty cool, huh? So
yeah.
With that, I'm going to leave it to Guy. We have about 10 minutes left. He's going to be showing some Excel awesomeness.
Yeah, so let's move to this one.
Oh, you want to use slides?
Yeah, yeah.
Number 8.
Yeah. So first of all, it was mentioning that whatever you saw is also available in Excel. Excel shares exactly the same technology behind the scenes as Power BI Desktop. It's all powered by Power Query, right? And so, how shall I? Just give me a second. Yeah, so I'll walk you briefly through the history of Get Data Experience in Excel, and then I'll do another demo for you. So this is briefly the journey that we started a while ago to modernize the Get Data Experience in Excel. Back in 2010, 2013, the only Get Data Experience in Excel was what we call a legacy Get Data Experience, right? Get external data chunk under the data tab of the ribbon. And it was a Power Query engine, which you could download and install. And obviously, we saw that, hey, Power Query is a good technology, it's amazing technology, allows you to do a bunch of transformations easily. by just clicking on a ribbon and things like that. And so we started the journey to modernize the get data experience in Excel. In Excel 2016, we natively integrated Power Query technology in Excel, so you don't need to download the add-in anymore. It was there on the data tab of the ribbon right in front of you. You had two data experiences, the legacy one and the get external data section, and the modern one based on Power Query technology and the chunk called get and transform on the data tab of the ribbon. And these days, we're actually completing this journey and hiding the legacy experience and making sure that the primary experience to import and shape data in Excel will be through Power Query. And let's switch to my laptop and show you how it looks. So what you see, if you're an Office 365 subscriber, you should start getting this modern experience these days. We already started releasing it to production. This is how the new and redesigned data tab looks like, right? You have the most popular connectors right there in front of you. You can import from text, from web, or from table and range. This is something that is unique to Excel. Obviously, you can import from a table in your worksheet, right? If you need more connectors, you can go to get data and browse through the same connectors arranged by category through the same connectors as Miguel has shown before. You also can click on Queries and Connections button, and this is where you can manage all the workbook queries and connections. This was not the case before. The management experience for workbook queries and connections was done from two different places, and we consolidated this so you can manage your workbook queries and connections in a single place through the side pane. And so I'll do another demo for you, and my demo goes like this. Let's say that, hey, I'm going to vacation, and on my vacation I like to dive, and I would like to find the safest diving location so I won't be eaten by sharks. And so I downloaded some data from the web with shark attacks, real data, by the way. I have data only for these countries, Australia, South Africa, and USA. Let's click on the CSV file to take a look how it looks. I have a location, right, and I have the number of attacks per different locations per years. And now I need to combine the data from all the countries, right, find the location with the least number or zero number of shark attacks and hope that shark knows statistics and will not eat me this time. So yeah, let's start. I will start with importing from CSV. I will choose Australia. Wait a couple of seconds, and here you can see the preview of this CSV file. And Power Query does a lot of magic for you behind the scenes, as you can see. It automatically detects a lot of things for you. In this case, it detected the delimiter and already splitted the columns for you, right? I will click on Edit and go into Power Query. Same Power Query as you saw before. I'll do a couple of transformations. First of all, I will use first row as headers, right, this one. And then I will add another column for a country. Custom column. Country, Australia. Australia, right. I will use this column to filter out the locations later on. I will click on OK. Let's just move this column to the beginning. Click Close and Load. We now support loading query into a pivot table or pivot chart. This was not the case in Excel 2013, right? You could only load into a table or create a connection only. I will create a connection. Here we go. I have a connection created for me. I actually need to repeat this step for the remaining countries. So I'll skip it, and I will just open a file which already contains these queries for me. So here I have data for Australia, South Africa, and USA, right? All the queries are saved as connection only. I need to append the data together, so I will go to Combine Queries, Append, choose all the three columns that I would like to append together, click OK. OK, I'm in the query editor again. So I need to do a bunch of cleansing operations and transformations before I can analyze this data in a pivot table. Let's clean the locations column a little bit. It contains spaces, as you can see, right? It contains some meaningless locations, like 1 kilometer of black. I have no idea what it means. And it also contains duplicate rows like this, right? So I'm going to clean this. First of all, transform, format, trim. We'll clean the spaces. I will filter out the locations, meaningless locations, and I will also remove duplicate rows, remove duplicates, just like this. I'm done with cleaning the locations column. Let's focus on the data. So I will remove the old data. I would like to focus on the recent data only, so I will remove these columns.
Because those sharks have already died?
Yeah, probably. Yeah, it's always good to have focus on recent data when you're doing shark analysis. Please remember this. So my data has nulls, right? I will replace it with zeros. Again, just in one click, I will go and click replace. Now, 0. And hey, I'm almost done, but I can't analyze this data in a pivot table. I need to flatten this information, so I will do it with a pivot operation. Just right-click and pivot columns, and this is another magic. So it just kind of flattens the data and creates an attribute value columns for you. Attribute stands for year, in this case, and value stands for number of attacks. And we are done. We can load the data in a pivot table. Let's click close and load. Load the data into a pivot table report. Let's close the queries and connections side pane. Grab a couple of fields into a pivot table. Country. Sort the locations by sum of attacks. Yeah, and here we go. I have the safest location to dive, and I can go and dive here. And I will probably send my manager over here, right? And I will tell him, hey, I did the analysis. It's safe to dive here. And so you've seen a lot of, you've seen how it works in Excel, right? Exactly. Again, we share the same technology behind the scenes, Power Query. You can do the same transformation, including column form examples in Excel. We release updates on a monthly basis to the, updates to the get and transform experience. So it comes with a slight delay of a month or two, right? So first you see the feature coming in Power BI Desktop, and after a month or two you will see them in Excel. Yeah, we hope you like the new Get Data experience that I just showed you.
Cool.
That's it. Thank you.
So a couple more things. We're over time, but just wanted to share a little bit of what we're working on so you can see what to expect in those monthly updates. Being the data connectors and gateways team, we of course are working on new data connectors. So things like IBM Netezza, we released a Power BI desktop update yesterday that includes a new Netezza connector with both import and direct query options. Google BigQuery and ServiceNow are two connectors that are highly requested. If you go to our user voice forum on ideas.powerbi.com, you'll see there towards the top. So we're working on those as well. SAP BW Direct Query, also a feature that we released as a preview yesterday. We have a session later this afternoon about connectivity to SAP data sources, including HANA and BW, so it might be interesting for some of you. The Data Connectors SDK, we talked about this earlier, but there's a session starting in about 15 minutes where Matt Mason is going to cover M in depth, and he's also going to show how to build a connector from scratch using the SDK. And last but certainly not least, new data transforms and other query editor enhancements. So things like the by example feature that you saw. We do that based on customer feedback, so keep your feedback coming as usual. And go both at ideas.powerbi.com for what you'd like to see next. With that, we can take a few questions at the back of the room to let the next speakers get set up. And thank you so much for coming again.
Thank you.